Have you ever wondered what happens when more than two charges interact with each other? Welcome to the fascinating world of physics, where we're going to explore the forces between multiple charges. This concept is not only a fundamental part of physics, but also plays a crucial role in our everyday lives. Imagine this: without understanding these forces, we wouldn't have the technology we rely on today, such as our mobile phones, computers, or even the electricity that powers our homes. Yes, the forces between charges are that important. In class 12, this topic is often studied in depth, helping students to understand and appreciate the invisible forces that govern our universe. From the tiny particles in an atom to the vast expanses of the cosmos, these forces are at work, shaping our world and beyond. So are you ready to dive into the world of charges and forces? Let's get started. First off, we need to understand what a charge is. Picture it this way: just as the Earth has gravity that pulls objects towards it, particles too have a property that pulls or pushes other particles around them. This property is what we call a charge. Now, charges can be created by gaining or losing electrons, those tiny particles that orbit the nucleus of an atom. There are two types of charges: positive and negative. Positive charges come from losing electrons, while negative charges come from gaining them. A key thing to remember is that similar charges repel each other, so two positive or two negative charges will push each other away. On the other hand, unlike charges attract each other. A positive and a negative charge will pull towards each other, much like magnets. Now that we have a basic understanding of charges, let's move on to forces. So, what exactly is the force between charges? Well, let's dive into this fascinating concept. The force between charges, also known as electrostatic force, is a fundamental interaction that governs how charged objects interact with each other. And the law that describes this interaction is known as Coulomb's law, named after Charles-Augustin de Coulomb, the French physicist who first formulated it. Coulomb's law states that the force between two charged objects is directly proportional to the product of their charges, and inversely proportional to the square of the distance between them. In simpler terms, it means that the bigger the charges, the stronger the force. Conversely, the farther apart the charges are from each other, the weaker the force becomes. Let's imagine it like this. Picture two magnets. If they're both very strong or highly charged, they'll pull or push each other with a lot of force. But if we move them farther and farther apart, the force between them decreases. The same principle applies to charges in Coulomb's law. However, it's crucial to remember that the force can be either attractive or repulsive. Like charges repel each other, while opposite charges attract. If you've ever played with magnets, you'll remember the struggle of trying to push two similar poles together. That's repulsion at play. Now, the direction of this force is along the line joining the centers of the two charges. So, if you have two charges, imagine a straight line connecting them. The force will act along this line. Let's not forget the role of the medium surrounding the charges. Different media can affect the force between charges. For instance, the force between charges in water is different from that in air or in a vacuum. Now, this is all well and good for two charges. But what happens when there are more than two charges? When more than two charges are involved, things get a little more complicated. This is where the principle of superposition comes into play. The principle of superposition is a fundamental concept in physics, and it's absolutely crucial when we're dealing with multiple charges. So what is the principle of superposition? Well, it's a fancy way of saying that when several forces act on an object, the net force is simply the vector sum of these individual forces. In other words, you just add up all the forces to find the total force. Now, how does this apply to charges? Let's say we have three charges: charge 1, charge 2, and charge 3. To find the net force on charge 1, we first calculate the force between charge 1 and charge 2. Then we calculate the force between charge 1 and charge 3. We then add these two forces vectorially, considering both their magnitudes and directions, to get the net force on charge 1. Remember, the force between any two charges depends on the product of their charges and the inverse square of the distance between them. So if the charges are the same sign, they repel each other, and if they are of opposite signs, they attract each other. Let's make this even clearer with an example. Imagine three positive charges, all of equal magnitude, arranged at the corners of an equilateral triangle. The net force on any one charge is the vector sum of the forces due to the other two charges. Since the charges are all the same and the distances between them are also the same, the forces between any two charges are equal. The forces are also in the direction away from each other because like charges repel. So if we add these forces vectorially, we find that the net force on each charge points towards the center of the triangle. And that, in a nutshell, is how forces between multiple charges work. This principle of superposition allows us to simplify otherwise complex situations, making it easier to understand the fascinating world of electrostatics. Let's quickly recap what we have learned today. We started off by understanding the concept of charge, a fundamental property that forms the basis of electricity. We then delved deeper into the fascinating world of physics to explore the force between charges. We discovered that similar charges repel each other, while opposite charges attract, a principle that governs so much of the world around us. Subsequently, we navigated the complexities of the force between multiple charges. We found out that when we have more than two charges, each charge experiences a force due to every other charge. The total force on any charge is simply the vector sum of the individual forces. These concepts are not just theoretical ideas. They are the building blocks for many phenomena we observe in our daily lives and crucial for Class 12 physics. Keep exploring, keep learning, and remember, the world of physics is full of fascinating phenomena waiting to be discovered. Until next time, goodbye and take care.